Halfway through, not just probably more than halfway through. Okay, so this presentation is about laser safety. I just took a few pictures of lasers that I have in the optics lab. They look obviously different than that. And here are the primary dangers when you are working with lasers. Obviously, if you get them into your eye, you can do damage to your retina or another eye tissue, damage your skin tissue if you have a high enough powered laser. Then if you're working with laser dyes, be very careful because these can be very toxic chemicals. You can also get electrocuted by high voltage power supplies, or if you have a high powered laser, you may cause a fire. Why can lasers burn holes into the retina? Well, mainly it has to do with the intensity of the light. So power is energy per unit time, as you know, and intensity is power per unit area. They're very collimated, and therefore it's easy to overpower or to burn the rods in your retina. Also, they have a narrow line width, which contributes to the fact that there's no chromatic aberration that diverges the light as it passes through your eye's lens. And then finally, invisible lasers can enter your eye unnoticed. You may not know until you hear maybe a popping sound, which is one of the anecdotes that Matt told me or told us or used to tell us about a student who heard a popping sound and then realized he had been exposed to an invisible laser without noticing it. So there are various standards and safety guides. One of them is the ANSI standard, American National Standards Institute. They talk about maximum permissible exposures. And here are some examples. A green laser, 3 microwatt times 0.25 seconds would be some kind of a maximum exposure. This 0.25 seconds time is a typical time that it takes you to close your eye. So if you get this laser into your eye and it's a 3 microwatt laser, this is going to be your exposure for this maximum permissible limit. So even class 3A laser pointers exceed permissible levels by a factor of 100 during the blinking time, which is the 0.25 seconds. So don't stare into a class 3A laser. The one I have brought was a laser pointer, which is actually a class 3A laser. Damage threshold for laser pulses shorter than 1 microsecond is thousands of times lower than for the CW lasers that are continuously on. The take-home message is almost all direct laser beams and their specular reflection can cause irreparable damage to the retina. Specular reflection is reflection from mirror-like surfaces, smooth surfaces like metal or an actual mirror or glass. Diffuse reflection is what you see here from a relatively rough surface. Laser dyes, we just heard a chemical safety presentation. Some of them are mutagenic, some of them are carcinogenic. Be very careful when you handle them. My recommendation is if you must handle laser dyes, get special training first. You don't want to discover later on you expose yourself to something that causes harm to your health. High voltage power supplies, always be vigilant around these high voltage power supplies for lasers. People have died from electrocutions, and if voltages are above 15 kilovolts, you may also consider exposure to X-rays. Protective clothing and eyewear for a high power laser. You need protective gloves and clothing in certain circumstances so you don't suffer accidental burns. And depending on the laser classification, you may need appropriate protective eyewear. So this is from ANSI, and ANSI has a standard that you can buy about laser safety. It's about 200 pages long, costs about $800 as well. This is kind of the laser classification coming out of it. They define an accessible emission limit of a laser, and that accessible emission limit determines what kind of a class of a laser you have. And I only got 1, 2, 3, 8 here, and the other ones will be in the next slide. Class 1 lasers have no accessible laser radiation in excess of class 1 accessible emission limits for any exposure time. In other words, you can't possibly, they're basically inherently safe. Now, if you have a class 1 laser and you happen to be a tinkerer, and you disable certain features on the class 1 laser, it may no longer be a class 1 laser. So for instance, if you have a CD player, there's a little laser in it, and it's classified as a class 1 laser because it only comes on when the thing is closed. But if you took this thing apart and disabled everything and just used that laser that was in there, you maybe find out it's a class 3B laser that's being used. So keep that in mind. Class 2 lasers are visible light only, and the blinking reflex can prevent eye damage. That's at least what ANSI says. I would still avoid even staring into a class 2 laser. There's a subclass of class 2 lasers like class 2A, where supermarket scanners are in there, and you can basically be exposed for quite a long time before any damage occurs. Class 3A lasers, they can be either visible or invisible. And then when they're invisible, then the accessible output limit is set much lower than if they're visible. You do not need to have protective eyewear for class 3 lasers, so you're all safe in here with my class 3A laser, as long as you don't stare into it. Class 3B lasers, now you need to start wearing protective eyewear for sure, because there is no way you can blink your way out of the situations. If you get it into your eye, there will be eye damage. Class 4 is super hazardous, I would say, highly dangerous, output powers of more than 500 milliwatts. If this was a class 4 laser and you looked at this spot of diffuse reflection, you'd already get eye damage. Generally, you can state that a laser is more dangerous with higher power, obviously, and obviously also with less visibility because you don't see it. And then higher intensity, stronger focus of light. So if you take a class 3A laser and you put a lens behind it, it will narrow the beam down to a very narrow waist, and if you happen to have your eye in the beam waist, the intensity could be very high and you could get serious damage as well. So here are some safety precautions. Generally, do not aim lasers at a person's eye unless you are an eye surgeon. Okay, that's the exception. Do not let laser beam enter the eye. Sometimes it happens inadvertently and it's not pleasant. Wear laser safety eyewear if the maximum permissible exposure is exceeded, means class 3B lasers and up. Do not view beam directly with optical instruments, because they can alter the collimation of the laser and make it narrow and the intensity higher. Depending on the laser, a key switch may be necessary to prevent unauthorized use of a laser. It is best to enclose beam paths as much as possible. So if you have something in your lab, consider, can I put a tube there so that the part of the laser light goes through a tube where you're less likely to be exposed to random scattering of light out of the intended beam path. And it's best to operate laser in a controlled access area, especially class 3B lasers. remove unnecessary specular reflecting objects on the beam path, shiny metal surfaces, etc. And during the alignment, avoid placing the eye near the axis of the beam path. Consider alignment eyewear to reduce the danger. Another suggestion when you do alignment is maybe you can use a filter that reduces the intensity of your laser, so that if you do accidentally get a little scatter into your light, that it's much lower intensity. Just enough that you can see actually where the laser light is going. Mount lasers firmly so that you don't accidentally bump into them and they get into your eye. And also post hazard warning signs at the entrance of laser use areas. Class 4 lasers, now it's getting super serious. Absolutely review laser safety procedures before operating any Class 4 laser. Enclose the beam paths as much as possible, again. The laser, a Class 4 laser, must be in a controlled access area secured by entryway controls, for instance, warning lights, interlocks, protective eyewear, etc. Has to have a key switch master control. The protective laser eyewear must be available and must be worn by all personnel within the laser controlled area, no exceptions. For laser beams which pose a serious fire or skin hazard, you need to use appropriate shielding between the beam area and personnel. If you can, use remote firing of laser, use video monitoring or any other similar means to reduce the likelihood that you will be exposed to that Class 4 laser unintentionally. And again, if full laser power is not needed, reduce the laser beam output with output filters and shutters to less hazardous levels. Beam backstops should be made out of diffusely reflecting material and fire resistant, because Class 4 lasers can set things on fire quite easily. And again, post hazard warning signs at entrances. This is a little bit of an overview that's easy to read about these laser classifications. So you have Class 1, 2A, 2, 3A, 3B, and 4. And you can see that the visible ones, only visible is 2A and 2. All the other ones could be invisible or visible. And here you can see that the direct ocular exposure becomes hazardous, starting with Class 3A lasers in very serious. And then skin exposure basically is Class 4 lasers, but also you could have it with Class 3B lasers if they are narrowed by some kind of optical instrument. This is also from ANSI Z136.1, which is that laser standard or laser safety standard of the American National Standards Institute. This is kind of more something that you should consider when you start building up a lab in which you use lasers, high-powered lasers. Think about these kinds of engineering controls that are recommended or required. So you can see, for instance, all the things that are required when you have a Class 4 lasers. I'm not going to go through all of those, but you should be aware that these kinds of standards exist, what you should be implementing. If you go to a national lab, like PNNL or so in Washington, they won't let you turn on any laser until they've gone through all these things. They have a special laser safety engineer, and if they don't give the go-ahead, you're not allowed to turn that thing on ever. So keep that in mind. Here it seems a little bit more lax at the university level, but we should actually take that quite serious. These are also some administrative control measures. What you should, as a supervisor, consider, there should be written laser safety procedures if you have a Class 4 laser. For class 3B, they're recommended. Class 3A, we don't have to have anything. Education and training is required, starting with 3B and 4 lasers and so forth. So again, I'm not going to go over all these details. Look at that and think about what you need in your lab. Protective equipment, again, eye protection, skin protection is required for class 4. And then for class 3B, required if the maximum permissible exposure limit is exceeded. Then this is not the ANSI standard or classification of lasers is not the only one. There is another one from the International Electrotechnical Commission, which is kind of considered a newer one. Here's the rough equivalency of the laser classifications. So class 1 becomes class 1 and 1M, 2 becomes 2 and 2M, 3A is 3R, 3B is also 3B, and class 4. And so these are kind of the rough equivalent blue classifications. The nominal hazard zone is some kind of a area in which these kinds of protocols and safety requirements are necessary. This is a space within which the level of direct scattered or reflected laser light emitted during laser operation exceeds the MPE, maximum permissible exposure. So by defining such a NHC, you can eliminate more restrictive class 4 laser controls if an area falls outside of the nominal hazard zone. So for instance, I guess you could have some segment of your lab being the nominal hazard zone and having some protective area around that, and this may alleviate you from some restrictions that you normally have to put onto maybe the door through which you come into the lab, so that you put it a little bit further back. Very important that these danger signs that you have, so that it is clear to everybody, custodians and so forth, that there is a laser inside. I'll just give you one anecdote about people not reading signs. I used to have a big magnet in room 101 in South Physics. We had big signs on it. High magnetic field, do not put any metallic objects and so forth in there. So one morning I come into the lab and there is an electrician on a metal ladder with his tools standing right in front of the magnet. And I said, "Didn't you read the sign?" He said, "Oh, I have read it. Tell me when you're going to turn on the magnet." I said, "Well, it's always on. It's a superconducting magnet." So somehow people have access, they ignore signs, they do it anyway. So be very careful. That's why a class 4 laser or let's say an invisible laser, you really have to be careful. Yeah.
And this is why in the front office, when you come to us and say you don't have your keys and you want to be let into a lab, we tell you no. Find another lab mate to let you in. We will not open a lab for anyone.
Okay. Most likely emergencies, incidents, obviously eye damage. Seek medical attention as soon as possible if you realize something bad happened to your eye. Skin burns, if it's minor, you can follow Matt's recommendation with the aloe vera or put cold water over your skin for a while and treat it. The emergency response guide here, we've mentioned that several times. In our case, fire and medical attention and maybe chemical spills in case you have one of those laser dyes would be relevant. And then look at them closely. And again, let me reiterate, you should report to occupational and environmental health and safety stuff that happens, just for these obvious reasons that you not only for being paid for your treatment, but also there's a requirement so that you know what kind of incidents happen in the university. Fire, you have to decide whether it's small or large, you know, if it's large, you know, call 911, if it's small, you can maybe try to get it out yourself. Spills, just look at that before you start working with the chemicals. Think about ahead of time, if I spill, what am I gonna do next? If you can only remember a little bit from my talk, remember this. Lasers are classified according to danger level and type. Know the classification and safety rules before you use them. It is almost never safe to stare into a laser or into the specular reflection of a laser. If you deal with laser dyes, read the material safety data sheet and don't mess with the dye before you know all the ramifications and proper handling procedures. And also finally, the safety lecture does not replace your duty to read through and follow the safety instructions provided by the laser manufacturers. Do you have any questions?
What is laser dye?
Pardon me?
What is laser dye?
Laser dye is usually an organic compound with which you can change the emission of the laser to a different wavelength. So it absorbs at some shorter wavelengths and emits at a longer wavelength.